Hello everyone, welcome to the channel. In this lesson we are going to solve another exercise. In here we have to check whether the number is an abundant number or not. What are abundant numbers? An abundant number is a positive integer whose sum of proper divisors excluding the number itself is greater than the number itself. Consider the example 12, which is the smallest abundant number. Its proper divisors are 1, 2, 3, 4 and 6. When you add them, you get 16, and 16 is greater than 12, and therefore 12 is the abundant number. Another example is 18. Its proper divisors are 1, 2, 3, 6 and 9. When you add them, you get 21, which is greater than 18, and therefore 18 is the abundant number. Another example is 24, which is also an abundant number. Similarly, we have plenty of abundant numbers. Now you may be thinking, what are the proper divisors? So proper divisor of a number is any number less than the number itself which divides it evenly is a proper divisor. So consider the example of 12. Any number which is less than 12 and divides 12 evenly is a proper divisor of 12. So what are the proper divisors of 12? 1 is smaller than 12 and it evenly divides it. Therefore it is a proper divisor. 2 is another proper divisor because it also divides 12 evenly. 3 is the proper divisor, it also divides 12 evenly. So we have got 1, 2, 3, 4 and 6 as proper divisors of 12. Now over here you might have found one thing. A proper divisor is evenly dividing the number. What that means is if you divide 12 by any number, its modulus is always going to be 0, right? It is always equivalent to 0. So in order to find the proper divisors, you will start from 1 to half of the number. You need not to go beyond that. If you will divide a number greater than its half value, the result will be fraction, stating that the number is not evenly divisible. Therefore, we will require sequence of number from 1 to half of the number. So in order to solve this problem, we will use the range function to generate the sequence of numbers starting from 1 till the half of the number which is input by the user plus 1. So what that means is if user has input n as 12, its half will be 6. If you will pass range with lower limit 1 and upper limit as 6, so it will generate numbers starting from 1 till 5. 6 will be excluded. So in order to generate number till 6, you will have to add 1 to the upper limit, and therefore upper limit becomes 7, and it will generate sequence of numbers starting from 1 to 6. And we will apply this logic in our code, and in there we will use for loop to iterate through all the sequence of number that range generate for us. Let us write down the code. And moving to the code cell, in here I will say user that input the number, and then I will typecast it. We will say that enter any number. So once the number is input by the user, we will also create another variable summation which will hold the summation of proper divisors. Initially it will be 0, and then we will say that for I in range start from 1 till floor division of n by 2 plus 1. So this is going to give us half of the number, and we will exceed the upper limit by 1, and then we will say that if n divided by I generates 0 remainder, then it is a proper divisors of n. So in order to find out the remainder, we are using the modulus operator. We are saying that n mod I is equals to 0. If it is, then it is a proper divisor. Therefore we will add that number to summation. So this loop will keep on iterating the sequence of number that range function has generated for us, and once it is completed we will come out of this loop, and outside this loop we will apply a check. We will say if summation is greater than n, in that case that number is a abundant number. We will say that n is an abundant number. If it is not, then it is not an abundant number. Let us execute this code. I'm going to pass 12. It says that 12 is an abandoned number. I'm going to pass 15. It is not. I'm going to pass 18. It is an abandoned number. I'm going to pass 24. It is an abandoned number. And 26 is not.